Hello friends, welcome to the channel Electrical and Automation. Dosto, friends, I have started this channel in English because in my one of the another channel Electrical and Automation, which generally I upload all the videos in Hindi. So there were the few people who wanted the videos in English because they're not able to understand the Hindi language. So I started this channel. Now from onwards, I will make a video which will be uploaded in both the language in the individual channels. In the video which I already uploaded in my Hindi channel, that will also be included into this channel also. By one I will be doing it. So the today's topic is very important, control wall CV, and control wall CV is the heart of the wall sizing. If we wrongly design the CV of any control wall, then definitely in the process we will face so many troubles. So it is important from any instrument personnel to understand the value of the CV and the importance of the CV so that the mistakes cannot be happen. So the basic definition of the CV says that when the wall is fully open, so the maximum flow can be taken out from the wall or coming out from the wall by a delta P, yani that means the pressure difference across the wall will be 1 psi at a particular temperature is the CV of that control wall. Suppose you will take a two example. One control wall having a CV of 130, one control wall having a CV of 60. So the control wall which is having the higher CV is having the more flow. So simple is that CV is higher, more is the flow. So move on to the next. CV versus wall opening means that when the wall is continuously opening up to 100%, the constant value of the CV is also changing because the CV value is the maximum 100% opening value. So at particular values of the opening of the control wall 25, 30, 45, whatever it is value, so the CV value is also different at different openings. Now inherent versus installed flow, that is the people generally do mistakes at this point. What mistake generally do, what we have calculated generally we when we designing the wall, we just take the value of the line size, delta P across the wall, and process temperature, process fluid, and we put the value into the calculator or any particular vent given to the particular vendor. It will give the value of the CV of the design control wall. But we do not consider the bends and the extension and the pipe size get reduced. So this extension, reduction, up down of the pipe, bends of the pipe create resistance which actually deviates the CV what we have calculated in the design section. So it is most of the time, not most of the time, every time when we design the control wall CV, we have to consider 20 to 25% maximum because there will be a piping and system resistance which can affect the actual flow. So bear this mind this point. CV for the different fluid, and also there is a misconception in the minds that CV of any control wall will behave same for the liquid, gas and steam. It is not like that. Every media has a different CV and every media has a different CV calculation method. So go for that. Now here is the CV. I will show the this is the basic equation for the fluid which is come under the category of the water. So you can use this equation by for calculating CV when the medium is water. Now move to the another aspect. Example, just we take a one example. Suppose you know the flow of any particular line which is a maximum flow. So the 100 GPM flow is running on that particular line and the pressure drop is 4 psi. So you put these value in the previous formula that I have shown. So you will get the value of the CV is 50. So that means the control wall having the value of CV 50. Now, what happens if the CV is wrong? The CV is wrong if your CV is more than what it designed. So it will create hunting and the process will get unstable, and the wall is also get a instability. If your CV is undersized, that means the wall opens permanently, but the your maximum flow, whatever the maximum demand of the flow, will not be reached. So the flow starvation will start coming. Now come to the ideal operation. So we what we have a experience and what the industry and the people which are in the instrumentation and the vendor recommends that whatever your minimum flow and the maximum flow, that will be come under the 30 to 70% opening of the control wall. So whenever you are designing any control wall, just ask your vendor, give the graph of the opening versus the CV flow. So your maximum flow should be come into the come under the 70 to 80% of the opening of the control wall. If you able to do this, then I am very sure and you will be definitely have a confidence that your control wall will be work very perfectly. Now choosing the right wall based on the CV. Right wall is, I just have taken a one example. Suppose you have a CV of 14 and you have a at the right hand side there is a graph of 3-inch and 2-inch wall. So CV is 14 is perfectly coming into the mid range of the 2-inch wall. So the 2-inch wall is the perfect for the CV 14. Now when you calculate a particular condition, now your CV comes 47. So 47, some people says that 47 is coming into the maximum of the 2-inch wall, but we do not have to go for the 2-inch wall because it will not come into the mid range of the 2-inch wall. So we always mentioned and we already mentioned and we always recommended that CV should fall into the mid range of the any control wall full or minimum CV values. So the 47 is perfectly lying into the mid range of the 3-inch of the graph. So we go for the 3-inch wall. Now suppose we have a CV of 35. Now again you raise a question that 35 is coming into the 80% of the 2-inch wall, but we already recommended that as try to make a control wall maximum flow up to the 70% of the opening. That is very much better. So we should go for the 3-inch. Still the 35 is coming to the mid category or lower mid category of the 3-inch wall. So the design tip is that always select the wall CV in a such way that CV lies into the middle of the flow curve. That is the thumb rule of any CV. Now, if you want to calculate the KV has a simple relation with the CV. That is, you are able to see in the screen 0.875 into a CV. Bear in mind that CV, the flow in the CV is meter cube per hour and delta P is in bar. If you put this value into this, then you will get the KV. KV don't have any units. That is why it is like written mentioning here. Why CV matters, that already we have discussed so much that for the correct wall sizing CV matters. If we do not have a proper CV, then our control wall size is also disturbed. If CV is not perfect, if CV is perfect, then stable control and accurate flow or level, whatever you want to control with the control wall, it will be properly stabilized and accurate. Avoid oversizing and hunting of the control wall, because oversizing and hunting of the control wall will affect your process. Now, key takeaway is this: CV is the wall of the DNA and the heart of the DNA. If anything is wrong with the CV, then you will definitely have a challenge in the controlling of the control wall. So now it's your turn. I hope I have explained everything clearly, very clearly. Now you can understand this method is this process is very important. Understanding of the CV is very important for choosing the right control wall. So please like this video and share the video and subscribe our channel for the future videos. Thank you.